Okay, this is the College Algebra Review, Part 2. I've already given you Part 1 for your review, and what that basically did was that reviewed over the first few sections of the test. The review, if you've looked over the first part of the review, I told you what you could expect from each of those sections. I have reviewed you from section 1.1, 1.2, 1.4, 1.5, and section 2.2, circles. So I have reviewed with you for 5 sections. There's 3 more sections that I have left I want to review with you. One of them is 2.3, the other is 2.8, and the other is 4.1, those 3 sections. Now, I'm going to review with you a little bit differently than I did for the other sections, which is why I put this on a different video. And one of the reasons is this. There are some things that I taught you in 2.3 in different places, and that I also taught you in 4.1 that I can pull together in one problem. There's multiple things that I can pull together. And so what I'm going to do is show you what it's going to look like on the test, how I will pull it together. I'm not going to ask it as individual questions. I'm just going to give you one big problem and ask you a whole bunch of questions. You'll see what I mean once you copy this. All right, so here's what I want you to do. Now hold up just a second before you start copying. I'm aware of the fact that part of what you're looking at is cut off over here. Here's what I want you to do. I want you to pause the video and copy as much as you can. And then once you do that, I'm going to slide it over a little bit and let you copy the other part of it. So pause the video right now. Okay, I'm assuming you just did that. Now I'm fixing to just slide it over just a little bit so that you can copy the other part of whatever maybe got cut off on that right side. So let me look and see what you're looking at. Slide it down just a little bit. Okay, so pause the video now and fill in this. All right, I'm going to come back and go over this with you in just a minute. I just want you to get it all down right now. All right, we're going to do the same thing here, number 2. What I want you to do on number 2, let's see. Let's see. Okay. Yeah, you can see everything you need to right there. Okay, pause the video and copy all of this. Okay, now there's a little bit more you need to copy at the bottom. These last 3 lines. Pause the video now and copy that. Okay, we'll flip it over. Now, let me see what you can see and what you can't. Okay, you won't be able, again, I'm aware that you can't see all of this. But pause the video now and copy what you can. Okay, now I'm just going to slide it to the right just a little bit, or my left. I'm going to slide it to the left and let you put in the rest of this problem now. Okay? I'm going to do the same thing again here. Okay, so pause the video now and copy as much as you can. Now, I'm about to slide it over a little bit so that you can copy the right side of this. Okay? Then the last part. Let's see. Okay. Yes. All right. Pause this video now and copy this. Okay. Now, I'm going to come back and explain that in just a minute. All right. So let's start right here. Let me show you what it'll look like on test. All right. On the test, I'm going to give you a list of ordered pairs like this. And I'm going to ask you a whole bunch of questions when I give you this. Now, when I give it to you, you may have 5 ordered pairs, you may have 3, you may have 12. But I'm going to give you a list of ordered pairs, and I'm going to ask you about 6 or 7 questions. First thing I'm going to ask you is, what is the domain? Now, if you'll remember, this is real easy here. The domain's all the first numbers. So, gracious, we don't need to miss that. Range is all of the second numbers. Then the next question I'm going to ask you, is it a function? Now, remember, it's a function if the x's does not repeat. So, -3, 5, 2, 10, -6. Is it a function? Yes, because the x's don't repeat. Now, is it a one-to-one function? Well, now we got to check the y's. Do any of the y's repeat? 2, 0, -8, 1, and 4. Yes, it's a one-to-one function because the x's nor the y's repeat. Now, on test, that doesn't mean that the one I'm going to give you is going to be a function and going to be a one-to-one function. It may or may not be. So, if it's a function, you look to see if the x's repeat. One-to-one function, the x's nor the y's can repeat. All right. Does it have an inverse function? Now, remember we said that the criteria for a function to have an inverse is it has to be a one-to-one function. So, if it's a one-to-one function, if this is yes, then this answer will be yes. If one-to-one function is no, then this will be no. Now, let me say this right quick. If you remember, did we cover all of this in one section? Heavens no. We covered domain and range in section 2.3, but we covered inverse functions in 4.1. So that's what I mean by saying how I can pull together questions that's in different sections but put it in one problem. All right, so does this have an inverse? Yes, it does. Why? Because it's a one-to-one function. So yes, it has an inverse. Why? Because it's a one-to-one function. Now, write out the inverse. Well, we talked about how to do that. To write out the inverse, what do? You just invert your ordered pairs. Your ordered pairs from the original, you just invert them, flip them over. You don't change the signs, you just flip them over. Now, the next question. Find f of 2. Now, how do we normally find f of 2? We take 2 and plug it into x's place, but we're not given a function. We're given ordered pairs. So here's what this is asking for. Find an ordered pair up top that has a first number 2. Find an ordered pair up top that has a first number 2. And whatever the second number is it's paired with it, that's what f of 2 is. It's -8. Same thing here. Find a number up top where the first number is -6. Find a number up top where the first number is -6. The number that it is paired with is what we're looking for. And then in this last one, f of x equals 0. This is the x. This is the y. This is the x. This is the y. So this 0 is the y number. It's not the first number. And we're looking for x. So go up to the top and find a y number of 0. Go up to the top and find a y number of 0, and we're looking for the x that it is paired with, which is 5. So I will give you one problem like this on test, where I give you ordered pairs and I ask you these questions. Okay, the next thing I'm going to do, very similar, is I'm going to give you a graph, and I'm going to ask you, what is the domain? Now, remember, the domain is how far the graph goes from left to right. Now, if you've watched your videos, we did about 7 of these together in the videos. So if you need to go back, this was in section 4.1 on domain of a graph. So the domain's how far the graph goes from left to right. So how far does this graph go to the left? Negative infinity. How far does it go right? It stops right here. Now, I don't want to know how high it goes. I want to know where it quits going right. So that's why this is negative infinity to 3. Now, the range is how far the graph goes from the bottom to the top. How low does the graph go? It doesn't have a bottom. We call that negative infinity. Does it have a highest point? Yes, it does. Here and there. So it has a highest point. So the range is how low to how high it goes, which is up to 1. Now, is this a function? Yes. Remember, a function has got to pass the vertical line test. Now, is this a one-to-one function? No, fails the horizontal line test. So this one is yes, this one is no. This one is yes. Is it a function? Yes. This one right here is no, because it fails the horizontal line test. So if I ask you, does it have an inverse function? How do you know if it has an inverse function? If it's a one-to-one function. Remember, this is yes, this will be yes. This is no, this will be no. So no, because it's not a one-to-one function. Now you say, well, if it was yes, how would I give you the inverse to that? We did not discuss that. We didn't talk about drawing inverses of graphs. All right, now, the last thing we talked about is increasing, decreasing, and constant. And so here's what you do. You start out, go to the very furthest left point on the graph, which is negative infinity, and start tracing your graph. Now I'm going up. So would that be increasing, decreasing, or constant? Well, if I'm going up, that's increasing. So you're increasing until you get to right here. Now I don't want to know how high you go. I want to know where you quit going up, at negative 2. So you're increasing from negative infinity all the way up to negative 2. That's where this comes from. Now, when you leave negative 2, now you're decreasing. And you're decreasing till you get to right here. Now, once again, when you get right here, I want to know the x value, which is 0. So you're going down from negative 2 to 0. Decreasing from negative 2 to 0. Then when you leave 0, you're going straight across. And you stay at 0 till you get over here to 2. 0 to 2, you're constant. And then when you leave 2, you're increasing again, and you increase till you get to right here, which is 3. So you're increasing from 2 to 3. So that's how increasing, decreasing, and constant works. Okay? Now, let me remind you right quick how to do these. Domain of equations. Now, I told you in the notes when we went over this was in 2.3. I said there's 2 things you have to watch for in domain of equations. Number 1, you can't allow division by 0. Number 2, you can't have negatives under square roots. And then I told you this. When you're looking for domain of equations, if you do not have an x in the bottom and you don't have an x under a square root, the domain is all real numbers. So on this first one, you don't have an x in the denominator, you don't have an x under a square root, that's why it's all real numbers. But then I told you this, if you have an x in the denominator, you ask yourself, what would make this be 0? So here's the math. You set this equal to 0. So you'd write x plus x minus 7 equals 0. Solve that, so that would be x equals 7. Now that's not what x can be, that's what x can't be. So it'd be all real numbers except 7. Likewise, on this next one, what you do is you ask yourself, what would make this denominator be 0? How do we work it? You take this denominator and you write 2x plus 1 equals 0. And you solve that. And when you solve that, you get negative 1/2. That is not your domain. That is what x can't be. So the domain to that is all real numbers except negative 1/2. Now, if you wrote that as an interval, if I ask it, it would be negative infinity, negative 1/2, parentheses, union, negative 1/2, positive infinity. Now, these next two are two completely different animals. Because these next two, your x is not in the denominator, it's under a square root. Now, what can we not take square roots of? Negative numbers. Remember what we said you do here is you take your radicand and you set it greater than or equal to 0. So here's what you do on this problem. You'd write x plus 3 greater than or equal 0 because you don't want it negative. And then when you solve that for x, you get x is greater than or equal to negative 3, which is your domain. On this one right here, you'd say 2x minus 10 greater than or equal to 0. Add 10 to both sides, so you get 2x greater than or equal to 10. Divide by 2 to get x greater than or equal to 5. Okay? Next thing. Equations. Functions. Are equations functions? Yes or no? Remember, there's two things. The biggest power of y for a function, biggest power of y cannot be even, and the y can't be in absolute values. Biggest power of y cannot be even. It's not. Y can't be an absolute value. It's not. So that's a function. Biggest power of y cannot be even. It's not. Y cannot be an absolute values. It's not. That's a function. Biggest power of y cannot be even. It is. That's why this one's not a function. Now, when you go to the one-to-one function, biggest power of x cannot be even. So this one right here is no for 1-to-1. Biggest power of x cannot be even and be in absolute values. That's why this one's yes. Biggest power of x cannot be even. It's not. And it's not in absolute values. But this one's not a function. So if it's not a function, it can't be a what? 1-to-1 function. So if this is no, the 1-to-1 part will automatically be no. So that's where these right here come from. Okay? Now let's talk about these next two. Probably on the test, I'm going to give you a question that states something like this. Are the two functions inverses? Yes or no? And I'm going to give you a function like this, and I'm going to give you a function like this. I'm going to give you the two functions. Now, here's what you have to remember how to do this. What you have to do is, you have to do f composed with g of x, and then you have to turn around and do g composed with f of x. When you do both of those, if you get an answer of x both times, then the answer would be yes. But if you don't get an answer of x, then the answer would be no. So on this one, you're going to have to do f composed with g of x and g composed with f of x. Now, I didn't do the work, but I will go ahead and tell you, so you practice the work. These two right here, if you do f composed with g of x and g composed with f of x, you should get x both times. So practice that and make sure you can do that just to show that. Okay, now this next one. Now this next one's a completely different question than this one. In this next one, here's what's happening. I'm going to give you one function and ask you to find the inverse function. So I'm going to give you this, and I want you to get to this. Now, how do we do that? This was in section 4.1. Let me remind you of it. There was 3 steps. Step 1, write this as y equal 3x minus 7. Step 2, interchange your x's and y's. And then step 3, solve it back for y. And when you do, this is what you're going to get. Now, I didn't put in the work here, but I gave you a problem and showed you what the answer is supposed to be. We did 3 of these. This is the last thing we did in the video in section 4.1. Last 3 problems we did. So when you follow those 3 steps, you should get this right here. Okay. Then the last thing I'm going to do on the test is this. And this comes from section 2.8. From section 2.8. And if you go back to section 2.8, you'll remember us doing this. In 2.8, I started out and I gave you 2 functions. As a matter of fact, in 2.8, I gave you 3 functions. And if you'll watch that video, or if you've got your notes, you should have your notes with you. If you'll look at your notes, we did a B, C, D, E, F, G, H, I, and we went all the way down to like W. I'm going to give you some of those on test. Now, am I going to give you that many? Heavens no. I'll probably give you about 6 on the test, where I give you the 2 functions. But let me show you some ones that I might would ask you. Just show you 7 or 8 that I might would ask. Make sure that if I give you a problem like this on test, you can answer any of these. That's 1, 2, 3, 4, 5, 6, 7, 8. That's 8 problems right there. Now I'll probably give you 6. Now remember, what's very important when you're doing these is you start out and you write what you're supposed to do on this right side. I will definitely give you an adding one and a multiplying one, and adding one at a number and a composition. Probably give you a couple of compositions, and I'll probably give you a composition at a number. So I'll probably give you about 6 of those. Now these aren't worked out, and again, the reason is you've got a bunch in your examples, but I'll give you about 5 or 6 of these to work on the test. So this concludes the review for your midterm for college algebra.